Alright, today we're going to finish off our chapter 10 topic, and we're going to continue with functions. So in the previous one we looked at adding and subtracting, multiplying and dividing two different functions and how that worked in terms of equations and graphs and plugging in values and so on. So composite functions are similar, except instead of doing operations with them, what we're doing is we're going to substitute one function in for the other. And there's two different types of ways to write it. They both do the same thing, just two different ways. So we're going to start with the first, and then we'll move on to the second afterwards. So a composite function is just taking two separate functions, and they can be anything, and we're going to substitute one of them in for the x of the other equation. So what that basically means is you're going to take the y value of one equation, whatever the y answer is, plug that into the x for the other, and then resolve it. So normally what we write this as, and most people prefer the brackets, we write it as f bracket g of x. So we'd pronounce that as f of g of x. So what that means is take the g of x equation. So you can see we got g of x on the inside. So you always sort of work inside out. So in this case we take the g of x equation and we substitute that into the f equation. So without any numbers or anything, the f of g ends up being, we just take that g equation and plug it in, so we get 2 times, but instead of having x, we put in the entire x squared plus 3x. And then the minus 2 stays the same. So then all we have to do from there is FOIL it out and simplify. So this one would have 2x squared plus 6x minus 2. And then we can also do them in the other order. It doesn't have to always be f of g, it could be g of f. So what that means in this case is now we're going to take the f equation and substitute that in. So our g equation is x squared. So we're going to have, instead of x, we're going to have 2x minus 2 squared. And then we're going to have 3 times 2x minus 2. So you just substitute one equation in for each x into the other equation. And that's it. So this one we could FOIL it out. We'd get 4x squared minus 8x plus 4. If we FOIL that one, FOIL this one, we get 6x minus 6. And we could put those together to be 4x squared minus 2x minus 2. And you can see our two answers are different, which is typically what happens. So when you do composition of functions, f of g is not going to be equal to g of f. It doesn't work the same if you go backwards. Okay? So let's look at an example now where we actually have coordinates. So this one we want to do f of g of 2. So we got a couple of different options. You can just actually plug in the 2. So we do just the inside part. G of 2 would be 2 plus 2 squared if we plug the 2 into our g equation. So that's going to equal to 2 plus 4, which would be 6. And then what we want to do is take that answer, the 6, and plug it into the f equation. So we'd have 4 minus 6, which would be negative 2. And that's our final answer. Or, if we want, we could do it like we did the previous question and actually substitute the equation in. So we take the g equation and plug it into the f. So that would give us 4 minus x plus x squared. And then we could plug in a 2 into that. So you'd have 4 minus 2 and minus 2 squared. Or we could do, let's leave the brackets on. So you'd have 2 plus 2 squared, which is 6. 4 minus 6 is negative 2. So we get the same answer either way. Most people prefer just plug in the numbers and then work with the numbers instead. So let's try the next one. So we got f of negative 3. So that means we're going to put negative 3 into the f equation. So 4 minus negative 3 would give us 7. And then we're going to plug 7 into the g. So 7 plus 7 squared is 7 plus 49 would be 56. And the last one, we got g of g of 1. So figure out g of 1. So plug 1 into g. It would be 1 plus 1 squared, which is 2. And then we're going to plug 2 back into the g equation because we have 2 g's. So 2 plus 2 squared, which would be 6. And that's it. So the second notation, it's just a different way of writing it. So instead of writing it as brackets, we write f of g, and we just use a little o. And a lot of kids will say it's fog. F of g would be fog, but it's the same thing. So what some people do is just when they see that, just think of it being as another set of brackets. So it works the exact same way. We just want to plug in this case, we're going to plug the g into the f. So that would be, take the root, plug it in for the x, you'd have root x minus 3, and that's it. If we do g of f, we take the x minus 3 and plug it into the other one, so that would be root x minus 3. And if we have a number, we can plug in the number into whichever equation we want. And this isn't going to work. Let's change the number to 12. So we'd have root 12 minus 3 if we just use the above equation, which would be root 9, which is 3. Or we could do it in 2 steps, plug the 12 into the f. So 12 minus 3 would be 9, and then put the 9 answer over here. Root 9 gives us the 3. So whichever way you want to do it, it works out fine. And that's it for composite of functions. So when you're doing these questions, you'll get graphing questions again. So let's just look at a quick graphing one. So let's suppose that's our f equation. And let's suppose I give you a v equation that looks something like that, a g equation. So if I said find f of g of 3, what you want to do is you got to figure out, okay, where's the 3? So we look at 1, 2, 3. And let's suppose g of 3 is at, say, 9. So we have the coordinate 3, 9. So that means g of 3 is 9. So then what we got to do is then take that answer, the 9, and plug it into the f. So we go on the f graph, go over to 9, and figure out whatever our y value is going upwards. So it works the same, except you just got to take the answer of one equation, or one graph, plug it into the graph of the second equation. And that's all for this topic.